Hey, glad you could join us. It's good to have you here. I know life gets busy, so the fact that you're here, ready to drift among the stars with me, means a lot. Let's take a slow breath together. Let everything else fall away, just for a little while. This is our space now. Quiet, curious, wide as imagination. Thanks for bringing your wonder along. It fits in perfectly here. If you enjoy calm stories about space, tap like it helps others find us too. Want more peaceful journeys through the stars? Like and subscribe. And tell me in the comments where you're watching from and what time it is there. I love seeing where everyone's tuning in from. Hey everyone, today we're looking into stars, but not just the ones you can see above your roof at night, not even the ones we can reach with the best telescopes, far past our own galaxy. We're heading into deeper territory, a place where stars might be born in not just one universe, but in many, maybe even in infinite ones. That's the question today. Are there infinite universes? Or are we just one sparkle in a vast, mysterious void? Let's take a step into the quiet. Imagine we're floating, not falling, not rising, just suspended gently in the velvet dark of space. The kind of dark that isn't empty at all, it's thick with silence and secrets. All around us, stars blink lazily, like they're just waking up. You can feel the hush here. It presses softly against your skin, like warm silk. Now, behind us, Earth is a tiny marble, blue and white, spinning slowly like it's dancing in a daydream. That's where our story began, yours and mine. But now we're lifting off that story and letting it drift. We're heading somewhere bigger. Look ahead. There's a golden haze forming. Not smoke, not dust, just light stretching in every direction, rippling with possibilities. This is where the idea of the multiverse starts to shimmer into view. And it's not a single idea, not really. It's more like a cluster of theories, each one a different kind of key, trying to unlock the same enormous mystery. Is there more than just this one universe? Let's start simple. Picture yourself standing in front of a mirror. You look into it, and maybe, just maybe, there's a version of you in there who blinked a split second later. One theory of the multiverse, called the many worlds idea, plays with that thought. It says every time something happens, every time you make a choice, even a tiny one, the universe might split, like a branching tree. One you goes left, one you goes right. One stays quiet, one speaks up, and each version keeps living on in its own thread of reality. We're floating now through a corridor of these threads. Each one is like a soft ribbon of color, twisting gently through the dark. Can you feel them brushing past you? Some are bright, filled with laughter and starlight. Others are quieter, dimmer, strange in a way that's hard to describe. You might wonder, are all these versions of you real? Or are they just dreams the cosmos hasn't finished dreaming? Reach out. You might feel the warmth of one thread passing your fingertips. That could be the universe where everything turned out just a little better. Or maybe it's the one where you took a different path entirely. You'll never know for sure, and maybe that's okay. But the multiverse isn't just about choices and mirrors. Some scientists, the dreamers with chalkboards and messy desks, think about bubbles. That's right, cosmic bubbles. Let's float toward one now. It's huge, almost 100 billion light years across. But from here, it just looks like a soap bubble, drifting in the dark. Inside that bubble, an entire universe. Stars, galaxies, time, and space, all swirling inside. Ours is one of these bubbles. And out there, more bubbles. Some too far to ever see. Some still forming. Some collapsing into themselves like tired sighs. Can you hear it? That faint hum? That's the sound of universes being born. Maybe not sound in the way your ears know it, but a feeling, like the pulse of a deep drum behind your ribs. That's eternal expansion, stretching space thinner and thinner, like taffy being pulled forever. Look around. More bubbles, some glowing red, others golden, a few deep and shadowed like they've never known light. You might be tempted to tap one, just to see what's inside. But don't worry, they're not fragile. Each one is sealed tight by something called cosmic inflation, which is just a fancy way of saying they blew up really fast and then floated away forever. You might wonder, if these bubbles never touch, how do we know they're there? Good question. We don't. Not for sure. But sometimes the edges of our own universe carry little hints, like a slight bruise on the cosmic microwave background, the faint leftover heat from the Big Bang. Some folks think that bruise might be where another bubble bumped into ours a long time ago, a cosmic nudge, a hello from a neighbor we'll never meet. Listen closely. Can you hear the whisper of that collision? It's like a soft pop, echoing through time. And now, picture yourself standing at the edge of everything. Not the edge of space, we don't think space has a clean edge, like the end of a table, but the edge of what we can ever see. That's called the observable universe. Past that, things keep going. Or maybe they don't. Maybe they loop. Maybe they repeat. Maybe there's a wall made of nothing, and beyond that, something else entirely. Something we don't have words for. Breathe in. The air here feels colder. Not cold like ice cold, like mystery. If the universe is infinite, it might not just be full of stars. It could be full of versions of this very moment. You and me, floating here, again and again, in a sky that never runs out. And if it's not infinite, then maybe we're a rare flicker, a precious and unlikely spark in the dark. Either way, it's beautiful, isn't it? Let's drift now toward a different kind of multiverse, one that feels more like an echo. In string theory, a set of ideas about tiny, vibrating strings making up everything. There are extra dimensions curled up so small we can't see them. And those dimensions might form other universes, layered next to ours like pages in a book, so close, but impossible to touch. You might feel that now, a faint pressure to your left. That could be a parallel world, only a breath away, separated by a sliver of dimension we'll never fit through. What's it like there? Is gravity stronger? Are colors brighter? Are stars colder? We don't know, but it's fun to wonder, right? And there's something freeing about all this. If there are infinite universes, then every version of you has a home somewhere. The bold one, the quiet one, the one who sings in front of crowds, the one who lives in a cabin on Mars. They're all out there, living their strange and wonderful lives. That doesn't mean this version of you doesn't matter. In fact, it makes you more special. You're the only you in this exact moment, in this exact story. We'll keep floating together. There's more to see. Let's move a little closer to that shimmer just up ahead. You see it? Kind of like a ripple in the dark, faint, like moonlight through silk. That's something called a quantum fluctuation. A tiny, unpredictable twitch in the fabric of everything. And believe it or not, some people think entire universes can come from those little hiccups. Imagine that. Something as small as a flicker in a vacuum could suddenly bloom into an entire universe. Galaxies, stars, planets, trees, oceans, dogs, all from a moment of spontaneous what if. And that's one more kind of multiverse. A quantum multiverse, where each possibility isn't just imagined, it's real. Somewhere. Every time a coin flips, there's a world where it lands heads, and a world where it lands tails. Tiny splits, endless branches. Not just you choosing tea instead of coffee, but maybe worlds where Earth formed closer to the sun, or never formed at all. Let's hover here for a moment, just above this branching sea. Feel the breeze, or maybe it's more like a tug from all these realities stretching out in every direction. You might sense the weight of choices you didn't make, but don't let that make you anxious. In this vast, shimmering network of possibilities, your presence in this one matters just as much as all the others. Maybe more. Because here we are, exploring it together. Now, you might notice something strange in the distance, a flash of symmetry, like mirrors turned inward. That's another multiverse idea, one that has to do with cosmic symmetry. Some scientists think the universe should be balanced like a perfectly spun coin, and if there's imbalance here, perhaps there's another universe balancing it out. Think of it like this. If time runs forward for us, there might be another universe where it runs backward. Not like rewinding a video, but truly reversed, where people remember the future and forget the past. Where causes come after effects. Hard to imagine, right? But out here, imagination stretches in every direction. Let's glide over to something else, an idea, a little colder, a little stranger. It's called the mathematical universe hypothesis. Basically, the thought is this: maybe reality is math. Not just described by math, but actually made of it. That every single law, particle, and moment follows a hidden geometric pattern. And if that's true, then any consistent mathematical structure might form its own universe. Picture a great library, stretching beyond sight. Each book is a different set of rules. Some are chaotic, some elegant. Ours might be the one where gravity pulls and light bends and atoms dance in a way that allows life. But in other volumes, maybe gravity pushes. Maybe time curls in on itself. Maybe nothing ever changes at all. And all those books, all those universes might be as real as this one. You and I are just turning the pages. Let's move again. Gently. We're drifting now past something warm. Not fire, exactly, but memory. Our own universe, still glowing faintly with its beginnings. That glow is called the cosmic microwave background. It's the leftover light from when everything was new and hot and dense, and it's one of the clearest clues we have about how our universe was born. Now, here's a quiet thought. If our universe came from an explosion of light and heat, the Big Bang, what came before it? Some folks think there was nothing. Others say, nothing doesn't even make sense in this context. But there's a bolder idea too. One where before our universe, there was another. And before that, another. Like breaths in and out. Expansion, collapse, rebirth. An eternal cycle. That theory, called cyclic cosmology, suggests that multiverses might not just exist in space, but also in time. Feel that? It's like a clock with no beginning, ticking softly behind your thoughts. Let's drift toward that soft glimmer on your right. It's not a star, it's a model, a visual representation of a theory called eternal inflation. It builds on the Big Bang idea, but adds a twist. After the initial explosion, space didn't just expand once and stop. Instead, it keeps expanding, endlessly. Like a balloon that never stops growing, and within it, pockets stop inflating and form their own stable universes. Our universe would be one of those pockets. And outside it, more inflation, more pockets, more universes, some like ours, some wildly different, some with no matter at all, some where stars form but never burn. Reach out your hand. The air feels thicker here, like it's charged with potential. These are young universes, still bubbling into being. We're surrounded by cosmic eggs, still warm. Now let's tilt gently downward. Below us, the dark seems to deepen, not threatening, just quiet. This space holds another possibility, the brain multiverse. In string theory, brains, short for membranes, are higher dimensional surfaces, like giant sheets floating in a higher space. Our whole universe might be one such sheet, and others, they could be stacked beside us, just millimeters away, separated by a fifth dimension we can't perceive. Imagine paper-thin universes, fluttering side by side in the dark. Sometimes, maybe they brush, and when they do, a burst of energy, maybe even a new Big Bang. You might feel it now, a gentle brush across your shoulder, like something vast and unseen just passed close. There's more. Let's talk about the anthropic principle. It's not a multiverse by itself, but it often comes up when we talk about these things. It's the idea that the universe looks just right for life, not because it was made that way, but because if it wasn't right, we wouldn't be here to see it. That might sound obvious at first, but here's the twist. If there are many universes, each with different rules, then it's not surprising that we ended up in one where life is possible. Most other universes would be sterile, silent, empty, but here, in this sliver of reality, stars burn just hot enough, planets spin just right, carbon bonds form, trees grow, you breathe. We exist because this universe allows it, and we're lucky. Or maybe it's not luck at all. Maybe in the grand roll of the cosmic dice, somebody had to get this outcome, and it just happened to be us. Now pause. Listen to the silence. It's not empty. It's thick with questions. Are these theories just stories? Or are they real? Well, here's the thing. We don't know, and we may never know. Most of these multiverse ideas aren't testable, at least not with our current tools. They might stay in the realm of thought experiments, forever just beyond reach. But they serve a purpose. They stretch our minds. They remind us that reality might be bigger, stranger, and more beautiful than we've dared to believe. And they give us something else too, perspective. Think about it. In a multiverse, you're not just small, you're uniquely small, a flicker in one strand of an infinite web. And yet, your thoughts, your feelings, your choices, they ripple through this universe like waves in a pond. Here, now, you matter. You might not exist in every universe, but you exist in this one. And that's enough. Let's drift on a little longer. Ahead of us, something new is forming. It looks like a spiral, not a galaxy, though it glows like one. It's a visual metaphor, showing how certain models of the multiverse overlap. Imagine a place where quantum multiverses, inflationary bubbles, and higher dimensional brains all intersect. A crossroads of realities. You and I are floating right through the middle. Everywhere you look, rules shift. In one direction, stars form in reverse. In another, black holes sing like tuning forks. There's a universe made of ice, where time flows in circles. And one made of fire, where matter constantly burns and renews. Each of them is plausible, none of them provable, yet all of them invite us to wonder. Let that wonder settle into your bones. Let it breathe with you. We'll pause here for a little while. Let the questions settle. Let the stars circle slow. That brings us just past 5. 0 words with spaces in total, counting both the first part and this second. I'll keep crafting it in this rich, steady flow, deepening the journey and building more factual, immersive content about multiverse theories, always in the same tone and first-person perspective. Would you like me to continue with the next segment right away? Du sagte. Continue, please. ChatGPT Sada. Absolutely, let's continue this calm and immersive journey. You're still drifting right here with me, and the stars haven't stopped whispering yet. We'll keep pulling in new facts, vivid moments, and gentle invitations, all wrapped in that soft, wondering tone. Let's pick up right where we paused. You and I are still in that spiral crossroads, floating without effort, as if space itself is carrying us. Around us, glimmers continue to spin outward ideas, questions, possibilities. It's strange how quiet the chaos feels. Infinite universes swirl like a silent snowfall, and yet, here inside it, there's only calm, a stillness so complete it feels sacred. Let's lean into that feeling for a bit. Do you see that shape just ahead? It's folding in on itself, almost like a blooming flower caught mid-motion. That's a visual metaphor for a closed universe, one that curves inward. Some models suggest that if a universe contains enough matter, gravity might eventually pull it all back in, causing a kind of cosmic contraction, a big crunch, as some call it. Now imagine this. What if that big crunch isn't an ending? What if, right after everything collapses, it starts again? Bang, expand, cool, collapse, bang again. Each cycle might have slightly different properties, slightly different outcomes. Maybe in one version, stars form faster. In another, the laws of physics bend a little to the left instead of the right. Those small tweaks could lead to completely different universes, one after the other, like beads on an endless string. Now reach out. You might feel a subtle rhythm slow, deep, like the pulse of a sleeping giant. That's the heartbeat of cosmic time, echoing from one universe to the next. And yet, not every model sees things looping. Some see a one-way path, a singular burst, and then nothing. But here's where it gets interesting again. Even if our universe ends, could something sprout from its ashes? A rebound? A branch? Some physicists wonder whether black holes, those mysterious, collapsed stars that devour everything around them, might actually be gateways, not to other parts of our universe, but to entirely new universes inside. Let's drift closer to one. It looms there, like a giant void wrapped in shadow, its edge glowing faintly, the event horizon. Once something crosses it, it never comes back. Not light, not time, not even a whisper. But what if what falls in doesn't vanish? What if it falls through? Some ideas suggest that inside each black hole, there's a kind of seed, a pocket universe, cradled in isolation. Maybe the laws inside are different. Maybe time starts fresh. Maybe it's like striking a match in the dark, and suddenly there's fire, space, light. If that's true, then universes might be growing inside universes, like nesting dolls, each one holding the next. And we, this place we're in now, could be just one inner layer of a much, much larger structure. It's humbling, isn't it? Let's pause again, just for a second. Let your body relax, your breath fall into rhythm. Feel how wide it all is, how deep. Even our biggest questions are small inside this vastness. But now, look up, or what feels like up, toward a cluster of orbs glowing green and blue. These represent fine-tuned universes. In ours, everything had to line up just right for life to exist. If gravity were slightly stronger, stars would burn too fast. If the strong nuclear force were weaker, atoms wouldn't hold together. If the universe expanded just a little quicker, galaxies might never form. There are dozens of these so-called cosmic constants, and they all seem oddly perfect for life. That weird perfection has led some to ask, did someone fine-tune it? Or are there countless other universes where the dials were set differently? Where gravity was too strong or too weak, where light never formed, or where matter never cooled. Universes that blinked into existence and went dark in an instant, silent, unseen, forgotten. But here we are in one where life emerged, where stars lived long enough to make carbon, where planets formed in the soft arms of spiral galaxies, where someone like you could sit still, listen, and wonder. And that brings us back to the anthropic idea. Maybe we're in a rare kind of bubble, floating in a cosmic sea filled with failed attempts. Not because we're special, but because we're survivors of cosmic trial and error. Let's lean back a little. Let the gravity lighten. Up ahead is something quieter, the landscape multiverse. In some versions of string theory, there's a nearly infinite number of possible ways to configure the basic shape of space. Think of it like hills and valleys stretching across a massive terrain. Each valley represents a different possible universe, one with its own shape, particles, and forces. They call it the string landscape. Let's drift above it. See all those dips and swells below us? Each one could hold a different cosmos. One where time flows like syrup, another where light is slower than sound, one with no stars, just endless oceans of hydrogen. One with no matter at all, just curves in space, endlessly folding. You might hear a soft wind moving through this place. It's not wind like on Earth. It's the sound of potential, of rules shifting, sliding, reshaping themselves into worlds. There's something haunting about it, but also beautiful. You might ask, could we ever travel between these universes? Honestly, probably not. The distances, if we can even call them, that aren't like miles or kilometers, they're more like divides in logic itself. Crossing from one universe to another might mean changing your very nature, your particles, your rules. You wouldn't survive. You wouldn't even exist the same way on the other side. But don't be sad about that. The mystery itself is a gift, a gentle one, something to hold close on quiet nights. And maybe, just maybe, traces of these other universes still leave footprints. Some researchers scan the night sky, looking for tiny temperature anomalies in the cosmic microwave background. Little cold spots, slight bruises. They wonder, could these be signs of past collisions? Places where our universe brushed against another, billions of years ago? It's a long shot, but wouldn't that be something? A fingerprint, a scar, a story told by leftover light. Now, before we move on, let's return to the idea of infinite. It's a word we use often, but it's slippery, hard to hold. If the multiverse is infinite, truly infinite, then everything that can happen must happen. Not just once, but infinitely. There would be infinite versions of you, and infinite versions of this moment, right now. Us, floating here, wandering, over and over, slightly different each time, or maybe exactly the same. It's dizzying, I know, but try not to spin, just breathe. Infinity doesn't mean you're lost in the crowd. It means you're part of a chorus, one voice in a cosmic symphony, singing across the void. Let's keep floating. We're not done yet. Over there, do you see that gleaming band of light, like a belt made of stars? That's a representation of universes with altered dimensional structures. In our universe, we live with 3 dimensions of space, left and right, up and down, forward and back, and one of time. But what if other universes have more? Some theories propose 10 or 11 dimensions. Some are wide like ours. Others are curled up tight, like invisible threads. Maybe entire worlds exist inside those tight curls, moving to rhythms we can't even sense. In those places, physics might not just be different, it might be unrecognizable. No atoms, no light, no time, just pure geometry, or something even stranger. You can almost feel it now, like a subtle buzz in your bones, as if the rules of existence are brushing up against your own. Hold still. It passes. Now, before we pause again, let's consider something deeply human. Why do we ask these questions? Why do we chase the idea of other universes? Why does it matter to know if there are more realities than this one? Maybe because it gives us perspective, maybe because it humbles us, or maybe just maybe because it comforts us. The idea that somewhere out there, every version of us gets a chance. Every dream finds a home. Every mistake, every misstep, every quiet regret gets balanced by another universe where things turned out differently. Not to erase this one, but to give it company. This moment we're sharing, here and now, might be just one in an endless sea. But it's ours, and that makes it precious. Let's tilt gently to our left. Do you feel that? A subtle shift, like we're gliding across a curve in gravity itself. Up ahead, a trail of lights is blooming small, delicate spheres like lanterns in a dark forest. Each one pulses softly, glowing from within. These are theoretical universes, sketched by human thought and imagination. Some burn steady, filled with galaxies just like ours. Others flicker erratically, unstable, unpredictable, and a few hover silently, dim as fading embers, universes where nothing quite worked, where physics unraveled, where time never started. You and I drift past them like travelers through a gallery of might-have-beens. And you might wonder, how do these theories even exist? How do we imagine something we've never seen? It begins with math. Quiet, careful equations, often born not to describe multiverses at all, but to explain how particles move, or how gravity works. But sometimes, hidden inside those calculations, unexpected possibilities appear, like a whisper from behind a door no one meant to open. One physicist writes an equation about inflation, and suddenly it suggests universes forming endlessly. Another studies quantum behavior, and finds that nothing ever collapses into one outcome, it splits. Again and again. Each time the cosmos gets a little more crowded. Let's pause over this one glowing sphere. It's soft pink, with lines curling like smoke inside it. This one represents a theoretical baby universe, a place that might pinch off from our own universe, like a bubble splitting from a larger one. Some physicists think this could happen in very special conditions, maybe even inside black holes. And when a baby universe separates, it carries its own rules, its own space, its own time. It's forever disconnected, sealed off by a kind of quantum curtain. You might feel that now, a cool breeze against your neck. That's the sensation of something unknowable drifting just out of reach. Now let's ease into a quieter zone. There's less light here, fewer sparks. This is the domain of philosophical multiverses, ideas that stretch beyond what can be measured. Things like the modal realism hypothesis, which suggests that every logically possible universe exists, not just physically, but metaphysically. You and I are now gliding between possibilities that don't even need physics to hold them up, just logic and thought. Over there is a universe where the laws of cause and effect work backward, where people speak in colors and think in scent, one where life exists, but not made of matter, only sound, echoing through fluid time. These aren't predictions, they're reflections, mirror thoughts of what might be. Still, some researchers argue that if something is possible in any coherent system, it must exist somewhere. You might wonder if that's science or speculation, and honestly, even scientists argue about that. But here, in this part of the journey, we don't have to decide. We're just floating through the gallery, quiet observers, gentle companions of the unknown. Let's dip downward. Below us lies something stranger, still a theory known as the simulation hypothesis. Now, this one doesn't describe other universes in the usual sense. Instead, it suggests that maybe our universe isn't real the way we think it is, that it might be a simulation, a vast, detailed model running on some unimaginable machine, in some other reality. Look around. See the grid faintly glowing beneath the stars? That's just an artistic hint, a visual echo of the idea. Maybe what we call atoms are just bits. Maybe the speed of light is a processing limit. Maybe gravity is a program's way of keeping things in motion. And if this universe is a simulation, then there might be many more. Other programs, other runs. Maybe we're version 3 million. Maybe this is just one of countless test realities. It sounds wild, I know, but some serious minds have taken the idea seriously, not because it's proven, but because it can't be entirely ruled out. And in a way, it's just another kind of multiverse, one built not from inflation or strings, but from information. You don't have to believe it. Just let it sit beside you, like a story told by the stars. Now turn gently. There's a brighter patch ahead, filled with spiraling threads, golden, copper, and pale violet. These represent timelines. Not universes that are completely separate, but ones that branch within our own. Some interpretations of quantum physics suggest that every time a quantum event occurs, say, an electron spins one way instead of another, the universe splits to accommodate both outcomes. This is the many worlds interpretation again, but viewed differently now, not as separate bubbles, but as intertwined strands, like a braid. Feel them? The threads brush gently past your fingertips. One of them carries a version of today where you never found this story, another where you're not listening but telling it. And somewhere else, maybe we never met, maybe you drifted elsewhere, through a different corridor of thought. It's strange, isn't it? How everything we are feels so solid, and yet, under certain theories, it might be just one strand among infinite others. But don't worry, we're still right here, together. Now let's move into deeper space. Ahead is a region we'll call the horizon field, not a real place, but a concept space, visualized for us to explore. This is where we gather all the limits, the edge of the observable universe, the boundary beyond which light hasn't had time to reach us since the Big Bang. But just because we can't see past it doesn't mean nothing's there. In fact, almost every model agrees, space continues beyond what we can see, maybe forever, maybe looping back, maybe folding into itself like origami. That idea brings us to topological multiverses. These aren't about other laws of physics or alternate timelines. These are about shape. Our universe might be shaped in a way that causes it to connect to itself. You could fly in one direction forever, and eventually end up where you started, like Pac-Man, walking off one side of the screen and appearing on the other. Some scientists have even looked for patterns in the microwave background that might show this looping, repeating circles, identical temperature patches. So far, we haven't found strong evidence, but that doesn't mean it's not true. The sky still hides many secrets. Feel the curve under your feet? It's subtle, but real, a hint of how the universe might wrap around itself endlessly. Now let's glide back upward. To your right, a new glow has appeared, soft blue, gently expanding. This represents meta-universes, the possibility that even the multiverse itself is part of something larger. A multi-multiverse, if you will, like nested sets of realities, each one creating or containing others. It's a big thought, one that loops on itself. And yet, even here, in this almost absurd vastness, we can still ask the smallest questions. Like, why this moment? Why are we here, floating through it? Maybe it's coincidence, maybe it's design, or maybe, just maybe, it's the only moment we could ever have. The one where time, space, and awareness lined up just right. And in all the possible universes, in all the infinite branches, here we are. You and I have been sailing through thoughts, through worlds, through ideas folded deeper than we can see. And now, as we pass through this wider band of light like a ripple frozen in space, something new waits just ahead. This is a visualization of what some call the level hierarchy of multiverses. It's a way of organizing all the possibilities, from the smallest, most familiar ones, to the wildest, most abstract. There are 4 main levels in this model. Let's glide through each of them slowly, gently, without rushing. Level 1. This one's the most familiar. It suggests that beyond our observable universe, past that horizon of light and time-space, just keeps going. Same laws, same physics, just more. If the universe is truly infinite, then somewhere out there, there's a patch of space exactly like ours, with a planet like Earth, with someone like you. And not just once, infinite times. That's not science fiction. That's basic math applied to infinity. With enough volume and enough variation, duplicates become inevitable. Somewhere, there's a version of you just a breath different. One word unsaid, one smile longer, one dream followed instead of forgotten. Let's float upward. The air here tastes like static, not harsh, just faintly charged, like the moments before a summer storm. Level 2. This one comes from eternal inflation, the idea we floated through earlier. Remember those cosmic bubbles? Each one a separate universe, sealed in its own pocket of space-time? Here, those bubbles aren't just places. They're rules. In this level, each bubble may have entirely different constants, forces, or dimensions. One might have stronger gravity. One might have no stars at all. One might never have cooled enough for matter to form. This level takes us beyond space into the structure of the cosmos itself. Reach out. You can feel the differences. That bubble passing by your left shoulder? It's heavier. Time moves slower there. That one to your right? It shimmers strangely. Light curves in unpredictable spirals. And far below, that barely visible flicker? No time at all. Just static geometry. Now we tilt, spiraling gently forward, toward level 3. This one's where quantum physics steps in. The many worlds interpretation. Every time a quantum event happens, every particle spin, every path not taken, the universe splits. All outcomes happen. Every possibility becomes real in some branch. Unlike level 1, these aren't spatially separate. They're quantum layers of the same unfolding moment, not distant in miles, but in possibility. Here, we drift sideways through probability itself. Watch, see that fork in the light? That's a quantum event just now splitting two realities. In one, a particle flicks left. In another, it goes right. The universe is split cleanly, with no fanfare, no sound, just quiet divergence. One world becomes two. This level isn't just full of other yous, it's made entirely of them. You might sense some of them nearby now, flickers, reflections. They're not ghosts, just echoes of you, living through every path you didn't take, all valid, all alive, all you. And then, as we reach the outermost edge of this spiral model, level 4, the boldest level, the farthest, the most abstract. Here, we're talking about universes not just with different conditions, but different mathematical structures, completely different foundations, not just a new language of physics, an entirely new alphabet. These are realities that follow no logic we understand, where cause doesn't lead to effect, where numbers mean nothing, where shapes don't close, where existence itself might look like noise to us, and yet, to someone in that world, it's perfectly ordered. This level challenges the very nature of reality. Let's glide past one. It looks like chaos shimmering, broken, flickering like a glitch in a dream, but as we pass through its edge, a strange sensation washes over us. Not pain, not fear, just unfamiliarity. Like touching a color you've never seen before. Breathe slowly. It passes. These levels aren't walls. They're frames, models, ways for our minds to hold the unholdable. And they help us ask a bigger question. If the multiverse is real, truly, fully real, what does that mean for meaning? Let's sit with that. Because if there are infinite versions of you, does this one still matter? If every outcome exists somewhere, is any choice really important? It's okay to ask that, to feel a flicker of smallness in all this immensity. But let's turn toward another thought. Yes, there may be other yous. Yes, there may be other paths. But this one, this particular moment, this quiet journey we're sharing, only exists here, now, between you and me. And you chose it. You're not just floating through possibilities. You're experiencing this one, right now, right here, with eyes open and heart soft. That's beautiful. That's rare. That matters. Now, let's drift again. Do you hear that distant vibration? Like the low hum of a cello string stretched across stars. That's the gravity of higher dimensional space, at least, as some string theorists imagine it. In those models, our universe might be a three-dimensional surface embedded in a higher dimensional space, sometimes called the bulk, and gravity might be the only force that leaks into those extra dimensions, which is why it's so much weaker than the other forces we know. Here, floating through this idea, we feel thinner, stretched but not in pain, as if our own shapes are folding slightly around extra directions we can't quite name. Don't worry, just let it move through you. Somewhere nearby, there could be another brain, another universe just a whisper away, close in space, but far in access, a breath away, and yet unreachable. Unless, someday, someone finds a way to fold space through those extra dimensions, to punch a hole, to make a bridge. We don't know if it's possible. But the question burns quietly, like a pilot light in a cold room. Could we ever cross? Could we ever say hello? Or are we destined only to imagine? Now look up. A new band of color is unfurling above us, not from a star, but from a calculation. These are bubble collisions. If our universe did form in an inflationary multiverse, then maybe, just maybe, it once bumped into another universe. Imagine two bubbles, expanding fast, crashing briefly at the edge. That impact could leave a mark, a circular pattern in the cosmic microwave background, a slightly warped patch of space-time, a whisper in the data. People have searched for those signs. Some even claim they've found hints, a cold spot here, an anomaly there, but nothing conclusive. Still, the idea remains that our universe might carry a scar from a cosmic sibling. Reach out your palm, feel the warmth of that possibility, gentle, flickering, hopeful. We are not alone. Not in the ordinary way, not aliens in ships, not voices across voids, but deeper than that. We may not be the only universe that ever was. And there might be others, right now, wondering the same. We're still in motion, slowly, quietly. The dark around us isn't empty, not even close. It's filled with memory and math, with old light and new questions. The air here hums gently against our skin, cool and constant, like wind through tall grass at night. Look to your left, that gentle streak of light curving downward like a silver thread. That's a visual metaphor, not a real object, but a way to hold on to something called the landscape of string vacua. It's a strange name, but here's the idea. In some versions of string theory, there may be as many as 500 different configurations of the universe. That's a 1 followed by 500 zeros. You can't picture that number, and neither can I. No one really can, but we try. That's what this thread is, a tiny symbol for the bigger picture. Each configuration could describe a different universe. Not just different matter, but different space-time, different dimensions, different ways that time might flow or even stop. Now imagine that number 10 to the 500, not as a single place, but as a terrain, a kind of cosmic mountain range, valleys where universes settle, peaks where physics grows unstable, plateaus where things balance just right. And we're drifting over that terrain now, not with our feet, with our minds. You might feel it beneath us, not solid ground, but a weight in the air, like pressure from thought itself. Every universe below holds different rules. In one, electrons repel each other harder. In another, they dance instead of spin. Some universes might collapse after a second. Others might last forever, cold, slow, patient. Each of those possible configurations is called a vacuum state. Not empty, not nothing, but balanced, settled, like a marble in a groove. Our universe is just one marble in one groove, a stable state in a vast rolling field of possibilities. Let that sink in. The laws we take for granted, the way stars form, the way light bends, the way time stretches, those laws might not be universal at all. They might be local, unique to our marble, our groove, our valley in the landscape. Somewhere else, those laws are strangers. And yet, life found a way to bloom here, to think, to wonder, to imagine everything else. Now glance just ahead. A shape is forming, not hard edges, but slow arcs, curling like ink in water. This is an abstract view of cosmic inflation, still unfolding even now. Space itself stretching faster than the speed of light. Not in violation of the rules, just expanding them, literally. During inflation, quantum fluctuations, tiny hiccups in energy get magnified into vast regions of space. Each fluctuation could become its own universe, its own bubble, like seeds on the wind, blown outward by eternal growth. We drift past one of those seeds now. It looks quiet, small, but inside, an entire space-time is unfolding, galaxies spinning, particles dancing, planets forming, maybe even minds, looking up and wondering the same questions we are. It's humbling, isn't it? How much can be hidden in a speck? Reach out with your hand, feel that bubble as it passes. It's not warm or cold, it's new, a feeling hard to describe, the feeling of first light, of first time, of something being born. And now, further ahead, do you see that web? It glows faintly, gold and blue, strung across the darkness like a net made of thoughts. This is a representation of causal structure, the idea that every event links to every other through time and space. But in a multiverse, each link might spin off its own reality. Imagine that each moment we experience doesn't just affect the future, it creates futures, forks, divergences, realities upon realities, nested like stories, inside stories. In one, you pause this story early. In another, you replay it years from now, late at night, when the world feels still. And in yet another, you hear it on a planet that isn't Earth, orbiting a star that glows green instead of yellow. All real, all possible, all branches from this single quiet moment. Now let's rotate not in space, but in perception. There's a new sensation rising from below, a pulse, gentle, repeating. This rhythm represents quantum decoherence, the process that makes one version of reality rise out of many. It's what makes a superposition collapse, what takes a cloud of maybes and turns it into something real. Some scientists say that process doesn't truly collapse anything. Instead, it just splits off paths. The cat in the box isn't alive or dead, it's alive and dead, each in a separate universe. Schrödinger wasn't joking. He was trying to show how strange it all gets when we follow quantum logic to its natural end. You and I? We're following that end now. We pass through a curtain of interference patterns, waves of light and shadow, looping into themselves. Every wave a question, every interference a choice. We don't hear answers, but we feel them echoing through us like ripples in warm water. Now let's rise. We're floating above a different layer now. The stars here are oddly still, fixed in place like lanterns in ice. This is a conceptual space for the block universe idea, the view that past, present, and future all exist simultaneously. That time isn't flowing, but simply is, like a landscape, laid out all at once. In a multiverse of block universes, every moment exists somewhere, not as memory, as reality. We hover now above a string of moments that make up your life. You can see them, stretched below like beads on a wire. Your first breath, your first wonder, the quiet choices no one saw, the loud ones that changed everything, and somewhere in the distance, the moments yet to come still invisible, but just as real. We're not jumping between them. We're not moving at all. They're all already there. It's a strange comfort, isn't it? That your whole life, every version of it might be part of a grand, unchanging structure, like a story already written, yet still being told. Now we turn again. We're headed toward a lattice of shimmering cubes, not real objects, just an artistic way to hold the next idea. The multiverse might be computational. Think about this. What if the universe is like a computer running a vast program? Not metaphorically, literally. Every event, every law, every bit of energy part of a computation. And if that's true, then other programs, other rule sets could run alongside ours. Simulations, sure, but also fully self-contained mathematical systems. Each one a universe, each one real to the minds inside it. You and I float gently through those cubes now, each one humming softly, encoded with its own syntax. Some are elegant, ordered like clockwork, others pulse irregularly, chaotic but alive. One of them glows red, a fast universe, where entropy runs in reverse. Another flickers blue, frozen, timeless, where nothing ever happens. All of them exist, all of them compute. And if you follow this logic far enough, you reach an astonishing idea that all possible mathematical structures, not just some, but all have physical existence. That reality is math, not built on math, but made of it. Let that idea move through you like wind through open hands. It's not cold, it's not harsh, it's just big, and you're part of it. The space ahead of us is darker now, not empty, just waiting, still, and in that stillness, something pulses, slow and vast, like the heartbeat of the cosmos. That beat? It matches the rhythm of physical law. Here's something factual to hold in your hands. The constants of nature, things like the gravitational constant, the speed of light, or the strength of electromagnetism, are not explained by any deeper reason in our current physics. They are measured, assumed, accepted. But what if they're different somewhere else? That's not just speculation. That's a serious consideration in theories like string theory, eternal inflation, and the string landscape. In these models, those constants can vary, not randomly, but based on the vacuum state of that particular universe. So we drift now past a region where light travels just a little slower. In that world, stars might burn longer, gravity might pull stronger, atoms might cling tighter. And in another bubble, gravity is weaker. Planets drift apart, stars can't form, matter never clumps. Those universes exist, at least, theoretically, but they wouldn't last long. They wouldn't make galaxies, or planets, or life. What you're sensing right now is called the anthropic principle. It's the idea that out of the immense space of all possible physical laws, we find ourselves in one that supports life simply because only such universes can be observed by life. We aren't saying our universe is special. We're saying we must live in one that allows us to exist. That may sound circular, but it's a key lens for interpreting the multiverse. We observe certain constants not because they're necessary everywhere, but because they're necessary here. Now drift slowly with me to your right past a slow-turning sphere of light, painted with tiny equations like scars. These are equations of general relativity, Einstein's masterpiece, a framework for gravity and the curvature of space-time itself. In most multiverse theories, those equations remain, but how they apply might shift. In some universes, the curvature of space is positive, closed, like a sphere. In others, it's negative open, like a saddle. And in ours, it appears nearly flat, balanced to an astonishing degree. So flat, in fact, that it raised one of cosmology's biggest questions: why? Inflation theory helps answer that. A tiny burst of exponential expansion early in the universe's life can flatten space to near perfection, like stretching a balloon so taut that every bump smooths out. And if inflation happened once, it could happen again. Not just once more, but eternally spawning universe after universe in a cosmic cascade. That's not just theory. It's backed by our best models and the observed uniformity of the cosmic microwave background, that faint afterglow from the Big Bang. We pass through it now, a whisper of ancient heat, just 2.7 degrees above absolute zero, but so consistent, so smooth, that it takes incredibly sensitive instruments to find its ripples, fluctuations 1 part in 100, 0. Those ripples? They're the seeds of galaxies, of stars, of us. And if you look close enough, if you read the pattern, you might see hints of other universes brushing against ours. People have looked. Some thought they saw a cold spot that might suggest a collision with another bubble, but nothing has been confirmed. Still, the search continues. Now let's float upward. Ahead, a new shape emerges. It's abstract, an infinite branching structure, like a tree whose limbs split endlessly. This is the many worlds interpretation of quantum mechanics. And this isn't fringe theory. This interpretation has deep roots in the mathematics of quantum physics. It suggests that every quantum event, every measurement, every decision, every random flicker causes the universe to split. Not metaphorically, literally. One particle goes left, universe A. Same particle goes right, universe B. And both exist. The core idea, the wave function, that blurry, probabilistic cloud, never collapses. It just evolves, smoothly, mathematically. Universes don't blink out, they branch. The math supports this view, but it leads to a mind-bending conclusion that every moment in your life where something could have gone differently, did. Somewhere, you took that job. Somewhere else, you turned it down. Somewhere, you never met the person who changed everything. Somewhere, you met them sooner. And those versions of you are just as real. Now we spiral into one of those branches. Slowly, softly, no fear. This universe is nearly identical to ours. Just one variable shifted one particle, one heartbeat ago. It's like stepping into a dream that almost matches your own life, but feels just slightly tilted. It's not a copy, it's a sibling. And there are infinite more. Every time a quantum event unfolds, the universe multiplies. This means the number of universes isn't just large, it's uncountable, beyond infinite in the usual sense. Now we pass through another field, this one full of tangled lines, glowing faintly. These represent Feynman paths, all the possible paths a particle could take. In quantum mechanics, a particle doesn't just take one route, it takes all routes, simultaneously. Every possible trajectory contributes to its behavior. Those paths don't disappear, they diverge into new realities. You might feel those lines brushing against your arms, now soft as cobwebs, but woven from probability itself. And so we drift into deeper space. Now we reach a region inspired by a more speculative idea, causal set theory. In this framework, space-time is not continuous, but discrete, made of indivisible events, like pixels in time. These events form a set, a network where each moment only influences future ones, based on a strict cause and effect chain. Some think this could be the true quantum gravity theory, the one that replaces general relativity at its core. Others think it might explain why the universe flows the way it does, why time has a direction, why we remember the past, but not the future. If the universe is a causal set, then other universes might be other sets, similar structures, with different shapes, different rules of linkage, different arrows of time. We float now past a chain where time loops a closed causal curve, not science fiction. This idea arises naturally in general relativity under extreme conditions like near-rotating black holes. Could an entire universe operate on a loop? Could time repeat, but with new choices each cycle? Possibly. In some models, yes. In fact, eternal return is a concept that spans both ancient philosophy and modern physics. We might have been here before. Now let's coast into a new space. This one glows with slow, layered waves like heat rising from a quiet desert. These waves represent entropy, the measure of disorder in a system. In every known universe, entropy increases. That's the second law of thermodynamics. But the initial state of our universe had incredibly low entropy. Why? No one knows. That's one of the biggest mysteries in cosmology. Some multiverse theories suggest an answer, that out of a vast sea of high entropy possibilities, low entropy universes occasionally bubble into being, rare, but inevitable, given enough tries. We live in one of the rare ones. That rarity makes this moment, your life, your choices, this very breath, statistically miraculous. We are, by the math, the unlikely ones. And that makes this journey and your awareness of it precious beyond measure. The darkness around us is changing again. Do you feel that? The air, if we can call it that, feels stretched, thinner, like silk being pulled at the edges. That sensation means we're nearing the edge of our own observable universe. This edge isn't a wall, it's a limit. Specifically, a cosmic event horizon, the furthest distance from which light has had time to reach us since the Big Bang. It's about 46 billion light-years in every direction. Beyond that, the universe doesn't end. We just can't see any farther. Yet. Most cosmologists believe that space continues potentially infinitely past that horizon. And if space is infinite, then every possible arrangement of particles must repeat. That's not science fiction, it's simple math. In an infinite, uniform universe, every finite configuration will recur, including ones that form exact copies of Earth, of you, of this very moment. Let that idea wash over you. Somewhere, far beyond our cosmic horizon, there's another version of you, sitting or floating or dreaming, listening to this exact story word for word. This is called the Level 1 multiverse, a term coined by physicist Max Tegmark. It's the most conservative form of the multiverse, based not on exotic physics, but on spatial infinity and uniformity. And it's hard to argue with, because if space is infinite, then repetition isn't just possible, it's required. Now drift forward with me. Ahead, the stars blink out briefly, not gone, just hidden. We're entering a zone where probabilities collapse into paradoxes. This region represents the measure problem in cosmology, a real and unsolved issue. Here's the idea. If there are infinite universes, how do we talk about likelihood? If every possibility happens somewhere, then what does rare even mean? Is it rare to find intelligent life? Or do intelligent beings simply find themselves in the rare places where they exist? This loops us back to the anthropic principle, but now it feels more urgent, more personal. Because if we can't define a measure, a way to compare infinities, then we can't assign meaning to predictions. We can't say what's typical or probable. It's like trying to guess the average size of a grain of sand on an infinite beach, without a ruler, or a bucket, or a way to count. So here we are floating in that ambiguity, listening to the quiet debate of physicists still unresolved after decades. Some propose cutoffs, others suggest weighting methods, But there's no consensus yet, and while we wait, we keep drifting. Now there's something strange ahead. Do you feel that tremor in the stillness? A flicker of thought that doesn't feel quite alive? This is where we talk about Boltzmann brains. Yes, that's a real term. In a universe that lasts forever, with random fluctuations happening over infinite time, there's a strange idea that occasionally, by pure chance, particles might assemble into a fully formed brain. A brain with false memories. A brain that thinks it lived a life. A brain that believes it's real just long enough to wonder before it dissolves. Statistically, these randomly fluctuated observers could vastly outnumber normal ones like us, who arise through biological evolution in stable universes. And that leads to a disturbing question. Are we Boltzmann brains? Almost no one believes we are, but it's a problem, a logic trap, and in some versions of the multiverse, it's hard to escape. This is why physicists care so deeply about the measure problem, because the answer changes what we are. It shifts the story we're living in. And now let's shift the scene again. Look to your right. You'll see a swirling distortion, not like a whirlpool, but like a thought spiraling into itself. That's a symbolic representation of a Gödel universe. Yes, Kurt Gödel, the same mathematician who changed logic forever, also proposed a solution to Einstein's equations of general relativity. His solution described a rotating universe, one that allows for closed time-like curves, paths through space-time that loop back into the past. Not just theoretically, mathematically. In such a universe, time travel isn't forbidden. It's built into the geometry of space. Does our universe rotate like that? Not as far as we can tell, but the equations allow it. Somewhere, in a different patch of the multiverse, it might happen. There, you could walk forward in time and end up where you began. A strange loop, echoing forever. Now hold on to that feeling. We're about to enter higher dimensions. The space around us bends not just left or right, but in directions we can't describe. Imagine trying to explain a cube to a flat piece of paper. That's what extra dimensions are like to us. In string theory, one of the leading candidates for a theory of everything, our universe may have more than the familiar 3 dimensions of space and 1 of time. It might have 10, or 11, or even more. Most of these extra dimensions are thought to be compactified, curled up so tightly that we can't detect them directly, but their geometry affects how particles behave, how forces work, how universes evolve. Each way of folding those dimensions, each geometry leads to different physical laws. That's the string landscape again. Each point in that landscape is a universe. You and I are drifting across one edge of it now, seeing outlines of Calabi-Yau shapes. Beautiful, 6-dimensional structures curled into themselves like origami in invisible space. They hum faintly, not with sound, but with resonance. Each shape defines a different universe, a different way for reality to unfold. In one, gravity is stronger. In another, particles are heavier. In some, there are no atoms at all, just fluid fields that never crystallize into matter. And all of it follows from real equations. This isn't fantasy. This is what the math allows. Now glide gently with me. We're approaching a bubble that feels faded, not broken, just quiet. This is a baby universe, a region of space-time that budded off from a parent. This can happen theoretically through quantum tunneling. In some models, our universe was born from another, via a fluctuation in a higher energy vacuum. Picture a hill with 2 valleys. The first valley is high, the second is lower. A quantum fluctuation lets a tiny region tunnel through the hill and drop into the deeper valley. That bubble expands and becomes its own universe. That might be what happened to ours. And right now, as we speak, other bubbles may be forming in the quantum foam beyond our reach. Each one could be the start of a new cosmos. New rules, new beginnings. And somewhere, in some far-flung, freshly formed universe, someone might be asking the same questions we are. Do you feel how quiet it's gotten? The kind of silence that isn't empty, but full, brimming, like the pause before something ancient speaks. This space we're in now, it's older than memory. The glow around us isn't stars, but information drifting like snowflakes in a void. We've entered what some physicists believe is the ultimate nature of reality, a hologram. Not like a sci-fi projection, not an illusion, but a very real possibility that everything we know, every particle, every law, every heartbeat might emerge from information stored on a distant boundary. This is called the holographic principle, and it's rooted in deep, rigorous work from black hole physics. Here's the idea. When matter falls into a black hole, its information seems lost, but Stephen Hawking showed that black holes emit radiation slowly evaporating over time. This creates a paradox. Where does the information go? In the 1990s, physicist Leonard Susskind and others proposed a resolution that all the information falling into a black hole gets encoded on its surface, not destroyed, like writing secrets on the skin of a sphere. And then came the leap. What if the entire universe works like this? What if everything inside stars, planets, you, me, is a projection of information written on a distant edge of space-time? It sounds impossible, but it solves real mathematical puzzles. And in some interpretations of string theory, particularly in the famous ADS, CFT correspondence, it's not just possible, it's necessary. So float with me now. Reach out. That shimmer you feel? That thin, cold ripple brushing your palm? That could be the edge. Not the edge of space, but the boundary where all information is stored. Every movement you've made, every photon's path, etched here, encoded forever. You're not a shadow. You're not fake. You're the real pattern. The projection is the reality. And somewhere out beyond that boundary, the code continues. Endless digits, unbroken logic. Now feel the tug beneath your feet, a gentle downward pull. We're gliding toward another anchor of cosmic truth. Black holes. You've probably heard of them as destroyers, devourers of light, monstrous and final. But they're far more than that. They're libraries. Every black hole is a vault of information, and every bit that crosses its event horizon leaves a faint, encoded trace on its surface, a pattern of quantum ripples. Some physicists believe that black holes may be the key to unlocking quantum gravity itself. And gravity, that quiet force you feel pressing your hand to your seat, holding oceans to planets, it's still the least understood of the four fundamental forces. Here's the strange thing. Gravity is the only force that doesn't have a fully accepted quantum version. That's why so many multiverse theories, especially those rooted in string theory or loop quantum gravity, try to unify it with the quantum world. Now picture us drifting toward a black hole, not falling in, just orbiting gently, feeling its mass curve space like a heavy marble on stretched silk. This black hole isn't just a singularity, it's a test. Because in many ways, black holes sit at the crossroads of everything we don't yet understand: entropy, information, quantum mechanics, time. And in some speculative models, black holes don't just end lives, they begin universes. Yes, a few physicists have proposed that the singularity at a black hole's core may bounce into a new Big Bang, creating an entirely new region of space-time. Think of it as cosmic recycling. In one universe, a star dies. In another, a cosmos is born. And that means every black hole could be a portal to a new universe. Now drift farther. Behind us, the black hole recedes. Ahead, a sweeping plane of light, flat and wide, like an endless mirror. This is the future, not just ours, but the ultimate fate of all things. Cosmologists think the universe is not only expanding, it's accelerating. That acceleration is powered by something we still don't fully understand: dark energy. This dark energy isn't dark because it's sinister. It's called that simply because we can't see it. We know it exists because we observe galaxies rushing away from us faster than expected. It makes up about 70% of the universe, and its effect grows stronger over time. If this continues, and it seems like it will, the universe will become colder, darker, and more isolated. Stars will die, black holes will evaporate, even atoms will break down, leaving only a thin mist of particles and stretched space. This is sometimes called the heat death of the universe, a final state of maximum entropy, where nothing new can happen, no energy flows, no structures form. But even in that future, even in that silence, the multiverse may continue. Why? Because quantum fluctuations don't stop. They're relentless. Even in the emptiest void, there's uncertainty, there's potential. And from that potential, universes can still arise, budding off like droplets, quiet, infinite. You might wonder how we can know any of this, how we dare to speak about things so vast, so far beyond sight. But every theory I've shared, every possibility, is grounded in real scientific work. We don't know which are true, not yet. But they're not fantasy. They're the edges of what reason, math, and observation allow. And you're not a passenger in this journey. You're part of the story. Every time you wonder, you add another branch to the great tree of possibility. You're the reason the multiverse is more than math. Because you're here, listening, imagining, exploring. Now feel the light shift again. It's cooler now, a bluish tint, like early dawn. We're entering a region representing cosmic inflation not just in our universe, but in the idea that inflation itself may be eternal. The theory goes like this. In the very first moments after the Big Bang, trillionths of a second space expanded exponentially. This wasn't just fast. It was faster than the speed of light. Not breaking the rules because space itself can stretch as quickly as it likes. This brief inflation smoothed out the universe, flattened it, made it uniform. But in eternal inflation models, that burst never completely ends. It just slows down locally, allowing bubbles of slower space to form. Each bubble is a universe. Our universe. Others. Infinite more. In these models, the multiverse isn't optional. It's baked into the math. Each bubble may have different laws of physics, different particles, different histories. And right now, just beside us, but beyond our horizon, new bubbles may be forming. Budding, stretching, igniting. Can you feel them? They're like dreams being dreamed by space-time itself. And each one carries its own future. In some, stars are never born. In others, they live for trillions of years. In one, maybe carbon never forms. In another, maybe gravity is weak enough for entire solar systems to drift like snowflakes. And in some rare, improbable, miraculous life emerges. Eyes open, ears listen, minds ask. Like yours, right now. The space ahead feels layered like pages of a book flipping at high speed. You might notice a blur of possibilities around us, colors that don't quite belong, sounds that start and vanish before they form. This is the region shaped by quantum decoherence. Stay close. This part of the multiverse isn't distant. It's right here, inside every decision, every particle, every breath you've ever taken. Let me explain. In quantum mechanics, particles can exist in multiple states at once. This isn't metaphor, it's real. An electron, for example, doesn't have a set position until it's measured. It's in a superposition, a cloud of probabilities. But what happens when the system interacts with the environment, when it gets measured by the universe? That's decoherence, the moment when superpositions break apart into definite outcomes, and one version of reality branches off from the others. Now look around. Each one of those pages flipping, it's a universe that split from this one the moment a particle's path was decided. That's the core of the many worlds interpretation. First proposed by physicist Hugh Everett in the 1950s, it says that every quantum decision, every flicker of chance, splits the universe, not just in big events, but in the tiniest things. Whether a photon goes left or right, whether an atom decays this instant or the next. Each possibility becomes real, somewhere. So right now, there's a version of you that paused for a second longer before reading this line, another who looked away, another who laughed, another who never found this story at all. And none of those are fictions. They're real, physical worlds just as real as this one, but unreachable. That's why this place feels so strange, because we're inside the branching itself, walking through the decisions that shape reality. Now focus on that hum in the distance. It's not sound, not quite. More like the echo of symmetry. We're passing through the idea of alternate geodesics, the different possible paths through space-time that particles can follow. In general relativity, matter moves along curves called geodesics, like the natural path water would follow down a hill. But in different universes, the shape of space-time itself might be different. Imagine a version of reality where the shortest path between two stars is curved, not because of gravity, but because of a different topology of space. Some multiverse models suggest that space can have alternate shapes, not just flat or curved, but knotted, folded, or multiply connected. You might walk in a straight line and end up back where you started. That's not fantasy. It's part of topological cosmology, a real field of study. Now reach out. Feel the fabric around us. It's warm, alive with potential. We're brushing against the idea of symmetry, breaking a process that shapes entire realities. In the early universe, forces were unified. Gravity, electromagnetism, the nuclear forces, all part of a single, elegant framework. But as the universe cooled, those symmetries broke. And that's what gives rise to different physical laws. Different symmetry breakings in different regions of the cosmic field may lead to universes with entirely different physics. Some may have no gravity, others may have more than 4 dimensions. Some may be flooded with light but never form matter. Each one is a branch, a new expression of broken symmetry. And now let's drift closer. Ahead, you'll see glimmers of strange particles, blinking in and out like dreams trying to take form. These are theoretical but not imaginary. Axions, gravitinos, neutralinos, all part of what we call beyond the standard model physics, the search for particles and forces that extend past what we currently know. Some theories, like supersymmetry, propose that every known particle has a partner, a twin, with slightly different properties. If these particles exist, they could make up dark matter, the invisible substance that holds galaxies together. And if dark matter behaves differently in different universes, which it might, then each cosmos could evolve in profoundly different ways. Some might be dense with galaxies, others almost empty. Now picture this. In some parts of the multiverse, dark matter might even collapse into stars of its own kind, invisible suns that light up nothing, but burn just the same. You and I can't see them, but maybe, in another universe, something can. Now listen. That whisper behind us? That's the sound of vacuum energy, the ground state of all fields in quantum physics. Even in total darkness, space has energy. This energy isn't just a background detail. It shapes how universes expand, how fast they stretch, whether they collapse or fly apart forever. And the value of that vacuum energy, often called the cosmological constant, is one of the greatest mysteries in physics. In our universe, it's very small but not zero. If it was slightly higher, galaxies would never have formed. If it were lower, the universe might have collapsed. Yet in the multiverse, it may take on different values in different regions. That's why some scientists say, we live in a Goldilocks universe, not too fast, not too slow, just right for life to exist. And maybe that's not coincidence. Maybe we're just in one of the few patches where life can arise, where minds can wonder, where ears can listen. Like you, right now. Still here. Still following. Still curious. Now feel the pull underfoot again, this time stronger. We're being drawn toward the edge of causal structure, a boundary that separates what can influence what. In relativity, information can't travel faster than light. That defines light cones, shapes that tell us what events can affect each other. But in some multiverse theories, causal structure breaks down. In quantum cosmology, for instance, space-time might not be fundamental. Instead, it could emerge from something deeper, a network of relations, or a web of entangled states. In this view, time itself may not be real, not in the way we think. Instead, the illusion of time could emerge from quantum entanglement, the spooky connection between particles that Einstein once called spooky action at a distance. And if time can emerge, then so can space. So can the laws of physics. So can reality itself. You and I are now swimming through that quantum sea where the rules themselves are in flux, where structure condenses from pure possibility. Look at that ripple ahead. It's forming a lattice, a weave of connections. Each point is a possible history. Each link is a moment of awareness. And together, they form a reality. This one, the one where you exist, where you chose to listen, where you wondered about the stars. This is not just a journey through theory. It's a story of what's possible. Feel the cold here? It's not the absence of heat. It's the nearness of abstraction. We're drifting through a space that doesn't shimmer with stars or buzz with particles. It hums with logic. Pure, stark, beautiful logic. We've entered the realm of mathematical universes. This idea, rooted in the work of physicist Max Tegmark, says something bold. that mathematics doesn't just describe reality, it is reality. Picture a perfect sphere, spinning endlessly in a void. That's not just a shape, it's a possible world. And if it can be described by math fully, cleanly, consistently, then in this view, it exists. That includes equations too vast for any human to write, shapes too strange for our minds to visualize, universes with 11 spatial dimensions, or curved timelines, or beings made entirely of logic gates. And what's wild is this: our universe, with its electrons, atoms, galaxies, and thoughts, might just be one of the simplest mathematical structures that supports self-aware life. Feel that pattern beneath your feet? That's not stone or dust. It's symmetry, it's ratio, it's reality, expressed in code. But what about this feeling you have that you are real, separate from the math? Hold on to that, because now we're turning toward one of the most unsettling questions of all. Are we in a simulation? Wait, don't back away. Don't think sci-fi. Think probability. In 2003, philosopher Nick Bostrom laid out a rigorous argument. If future civilizations can run simulations of minds, simulations as detailed as our own experience, and if they're likely to run many of them, then it becomes statistically probable that we are inside one. Here's how it works. Let's say, in the far future, people develop computing power so strong they can simulate whole conscious beings, including their memories, emotions, and environments. They could run billions of simulations, of ancient history, of alien civilizations, of branching decisions. Now ask, how many real people would there be in the base universe? Maybe 10 billion? But how many simulated minds would be running in all those simulated worlds? Billions, trillions, more. If the number of simulated minds vastly outnumbers the real ones, then, statistically, we're probably in one of the simulations. Not because it's certain, but because it's overwhelmingly likely. You might feel your fingertips tingle now. That's not fear. That's proximity to something bigger. What if this multiverse isn't just a branching forest of quantum decisions? What if it's also digital, a nested architecture of simulated worlds, running within each other like fractals? Each simulation can create its own like layers of dreams, endlessly folding inward. And if so, maybe you and I are both simulated, but that doesn't make us fake. Because what makes you you is your awareness, your curiosity, your emotion, and those exist, right now, fully. Reach out again. Do you feel that soft flicker just above your shoulder? That's memory not yours, but of a system. This simulation, if it exists, remembers where you've been, what you've learned. And here's a twist. Some scientists think that we could test this. If our universe has limits like a digital grid, or rounding errors in high-energy physics, those could be signs of the system underneath, like pixels at the edge of a screen. We haven't found any so far, but we've also only just begun to look. Now, drift with me towards something even stranger. We've passed through quantum branches, black hole births, simulated layers, mathematical lattices. So now, we reach one of the most radical ideas of all: modal realism. This isn't a physics theory, it's a philosophical one developed by David Lewis in the late 20th century. It claims something breathtakingly simple: all possible worlds are real. Not just physical ones, not just mathematical ones. All logically possible versions of reality, whether or not they follow our physics, or our logic, or our time. In this view, there's a universe where water isn't H2O, where logic is circular, where cause follows effect, and effect loops back into cause, where the very structure of existence is rewritten. And all of those are just as real as this. Let that settle in. You and I are floating in a world where stars form from gravity and atoms hold together with electromagnetism. But beside us, though unreachable, lies a universe where gravity repels, and thoughts drift like smoke between minds. Are those places less real because we can't visit? Not in modal realism. They simply are. Now turn slightly. Do you see that vast plain ahead? It's dark, still, but not empty. This is the realm of metaphysical multiverses, the deepest layer. Here, even the laws of logic can vary. Cause and effect, time and space, identity and change, all of it might be structured differently. Why talk about this? Because in pushing the boundaries of the multiverse, We're not just asking, what else is out there? We're asking what it means to be real, to exist, to choose. And that's where you come back in. Because if any of these multiverse ideas are even partly true, then you are not alone. There are versions of you in 1,000 lights, 1,000,000 shadows. Some older, some younger, some who chose differently, some who never asked these questions at all. And that makes this moment you, here, listening, wondering more precious, not less. You are one voice in a choir of infinite possibility, but this voice is yours. Now look up. Those waves of light, they aren't stars. They're memories of universes, bursting like bubbles, fading, starting, touching. Some scientists believe that the entire multiverse, if it exists, may not be eternal, that it may have begun, and that even infinity might come to an end. But until then, there are still more stories to drift through, still more fields of dark energy to feel, still more quantum shadows to reach into. And you're not just invited, you're already inside. You might notice something subtle now, a low vibration under your feet, like distant thunder, except it's not sound, it's the tremble of reality itself. We've passed through physics, through logic, through possibility. But now, we pass through information. At the deepest level, some physicists believe the universe is not made of matter or energy, but of bits, yes, no questions, binary choices, patterns of information woven into the fabric of everything. This is known as digital physics, and it reshapes everything. Imagine the cosmos as a giant computational process, not a computer made of wires and code, but one where the laws of physics themselves act like rules of a program. In this view, particles become data, motion becomes computation. Even space and time may be emergent, unfolding from the way information updates from one moment to the next. Physicist John Archibald Wheeler once said, "It from bit," that everything physical arises from binary information, the bit. And if that's true, then what we're walking through now is not just space. It's code, cosmic code, still running. Reach out with your thoughts. Imagine your hand brushing a glowing thread of information, the string of a universal program humming in the dark. Each thread vibrates with a yes or a no. Each one contributes to the pattern that gives rise to reality. And maybe, just maybe, these threads arrange themselves differently in different parts of the multiverse. That means some universes could run on totally different rules of computation, like different operating systems. Some may be crash-prone, unstable, fracturing after a few seconds. Others may be smooth, infinite loops, quiet, graceful, never-ending. And maybe this one, maybe it's just stable enough to make life possible. To make you possible. Now picture a world made entirely of light. No atoms, no mass, just waves and frequencies. That's not fiction. It's a possible solution to equations we already use, models where matter never condenses, where particles never clump together. You might float forever in that world and never bump into anything. Nothing would cast a shadow. No stars would form. But maybe, just maybe, a kind of awareness could still emerge from the play of light waves. An intelligence made of photons, humming through vast glowing corridors, knowing without touching. Now turn slightly. To your right, see that universe flickering with icy calm? That one is built on the strong anthropic principle, the idea that the universe must allow for observers like us, because otherwise, there would be no one to ask the question. It's not about ego, it's about logic. If trillions of universes exist, only a few will have the right conditions for life. And in those, conscious beings will ask, why is our universe so well suited to us? But here's the twist. In the multiverse view, that question has an answer, because it had to be, because we're here. Not because the universe was made for us, but because we could only exist in one where things worked out this way. It's not comforting, it's not bleak, it just is. Now, take a breath. We're going to dive through one more ripple. This one glows gold, then violet, then empties into stillness. We're brushing up against eternal inflation, the idea that our universe is just one bubble in an endless froth. In this model, the fabric of space-time inflates rapidly forever. In some spots, it slows down just enough to create a bubble, a universe like ours. But in other regions, it keeps inflating. Forever. Picture boiling water. Each bubble is a universe. Some big, some tiny, some bursting instantly, others holding. Each one with its own constants, its own physics, its own story. And what's strange is that this process never ends. Even as universes like ours grow old and quiet, new ones are still forming in the inflating space beyond. And so the multiverse becomes truly infinite. Not just in size, but in time, in complexity, in creativity, in mystery. You might wonder, can these bubbles ever meet? Could we collide with another universe? The answer is, maybe. Some theories suggest that if two bubbles collide, we might see the imprint, a strange pattern in the cosmic microwave background, the afterglow of the Big Bang. Scientists have looked. Some claim to see hints, but nothing confirmed. But just the idea that our sky might carry the bruise of a collision with another cosmos is enough to stir something deep in you. Picture yourself standing on a sheet of glass so wide you can't see the edges. Beneath it, nothing. Above it, stars. Not our stars, though. Bigger, older, sharper somehow. Like they're made of intention. Now feel the glass beneath your feet start to bend, to ripple, but it doesn't crack. It folds. Welcome to brain theory. Not brain like inside your head, but brain short for membrane, a concept from string theory. The idea is wild, but here's the simple version. Our entire universe might be a three-dimensional brain floating inside a higher dimensional space. Think of it like a slice of bread in a giant loaf. Each slice is its own universe, and if the loaf is infinite, then there are infinite slices. Some just like ours, others bent sideways or frozen in time or shaped like loops. These brains can float near each other. They can move. They can even collide. In fact, one theory, the ekpyrotic universe, says that the Big Bang wasn't a singular beginning at all. It was a collision between two brains. Two giant sheets of reality, bumping into each other in higher dimensions, creating a blast of energy that bloomed into space and time, and galaxies are galaxies. Feel that sudden wind on your face? That's the shockwave still echoing from that impact. Billions of years later, you're still riding it. And if brains collide once, they can collide again. In this view, the universe is cyclical. Each collision births a new cosmos, again and again. A rhythm that pulses far beyond anything we can measure. Even time, in this model, stretches differently. Look up now. See those glimmering bands? Like ribbons twisting through a void? Each one is a brain, passing silently through the bulk. That's what they call the space between universes. And somewhere in that bulk, there may be forces we can't detect. Not gravity, not light, not any force we know, but something that tugs on brains, bending them, drawing them together. Something that keeps the rhythm going. Now, listen closely. Do you hear that low, distant thrum? That's not sound. That's potential. The sound of new universes forming, not in fire, but in contact. A slow touch between dimensions. And somewhere, on one of those brains, maybe a universe very much like ours, another version of you is standing very still, just like you are now, listening, feeling, wondering. Not every version of you is different. Some are so close they feel like echoes. Others are wildly other-shaped by brains with different rules, different particles, different starting collisions. But all are real. In this model, reality is layered, not singular. And that layering leads us to one more strange idea. Have you heard of the landscape? Not hills and trees, but a conceptual landscape imagined by physicists studying string theory. In string theory, the tiny loops of energy that make up particles can vibrate in many ways, and depending on how they vibrate and how the extra dimensions are curled up, you get different physical laws. Each combination creates a new possible universe. And there are a lot of combinations. Like a Google of them, or more. That's a 1 followed by 100 zeros. A number bigger than the number of atoms in the observable universe. Each valley in the string theory landscape is a universe. And our universe may be resting in one of the low valleys, stable enough to allow stars, galaxies, and life. But others may be less stable. They could decay, collapse, transform. Some could pop in and out of being. Some may never form at all. And some, like this one we're in, may last long enough for life to gaze up and ask, why us? You feel that, right? It's like standing on the shore of a great ocean, not of water, but of possibility. Every wave is a different universe. Every ripple holds a different you. And all of it, every theory we've touched tonight might be true, or partly true, or pointing at something we haven't even begun to grasp. The multiverse isn't one idea. It's a symphony of ideas, all playing at once, all layered and strange and beautiful. And you're here not just listening, but riding the sound. We're gliding now through a calm stretch of space, or at least what appears to be space, though it hums with something a little different, a kind of low resonance that isn't from stars or gravity, but from probability itself, thick like a fog. You might feel it in your fingertips, this subtle tension between what is and what could be, because this realm doesn't just hold one universe or a cluster of them, but entire patterns of possibility. Here, each universe isn't shaped just by physics but by initial conditions, the way the first sparks fell, the exact tilt of a field, the faintest imbalance in a sea of early energy. That's all it takes, to make one cosmos bubble up with stars and another collapse into darkness, to make one with laws like ours and another where the speed of light is slower, or where gravity is stronger, where atoms never formed and life never had a chance. And this brings us to something fascinating, the string theory landscape. It's not just a poetic name, it refers to a proposed map of all the possible ways strings, those fundamental little vibrating loops at the heart of matter, can arrange themselves. In string theory, different ways of curling those extra dimensions, the ones beyond the three we walk through, and the one we count as time, lead to different kinds of universes. Scientists estimate there could be as many as 10 times 500 unique combinations. That's a 1 followed by 500 zeros. More possible universes than grains of sand, more than atoms in our known cosmos. And if cosmic inflation, that rapid ballooning of space in the early moments of time, is eternal, then those possibilities might all be real. Each pocket of inflating space could settle into a different version of reality, like droplets cooling into distinct crystals, each with its own rules, constants, forces, and fields. Now imagine walking through that landscape with me. The air feels cool and almost musical, like the fabric of these universes is strung tight, humming softly with the tones of their own physical laws. One universe glows a gentle purple, its stars burn cold and long, the beings there live in slow motion compared to us. Another shimmers red and gold, where time hiccups every few seconds, repeating and rebranching in stuttering loops. Another has no light at all, only pressure and touch awareness has formed not from sight, but from waves moving through dense, silent oceans. Feel that one brushing past you now, dense, muffled, timeless. And it's here we start to see, not every universe is designed for life as we know it. In fact, most probably aren't. But in the few that are the narrow Goldilocks band where stars form, chemistry is rich, and time flows just right. Beings arise who look around, just like us, and ask, why this one? Why do we live in a universe where things work so perfectly for life to exist? That's the anthropic principle. Not magic, not design. Just that if we're asking the question, we already live in one of the rare places where asking is even possible. In a sea of infinite dice rolls, it's no surprise that some will land just right. And if those dice are being rolled across a vast multiverse in string landscapes, in inflationary bubbles, in quantum branches, then our own finely tuned reality isn't mysterious. It's expected. And yet, expected doesn't mean unremarkable. Look around. Reach out. Let your hand pass through a mist of branching outcomes, every strand glinting with what could have been. Feel the warmth of a universe nearby that almost matched ours, except that water never formed. Imagine a version of Earth where trees glow instead of leaves, photosynthesizing, where your name is almost the same but spoken with a softer vowel, where you still exist but live beside rivers made of methane under a salmon-colored sky. These aren't stories. They're statistical shadows, curling off the edge of deep theory, drawn from the math, yes, but also from the fact that the universe, at its most fundamental level, appears to be not just a thing, but a set of all possible things. Let's just sit in that for a second. Float beside me here, in this gentle, endless sea of possibility, where the stars stretch on without edge, and the space between them feels both full and hollow at the same time. We're no longer drifting through a single cosmos or even among many. We're past that now, past the bubbles, the branches, the folds, the simulations, the quantum splinters. We've moved beyond every version of reality we know how to imagine. And so we arrive here in the space beyond infinity. If there are truly infinite universes, not just a large number, but a limitless, unending, uncountable set, then by definition, everything that can happen does happen, somewhere. Every possible version of you exists, not just once, but infinitely many times. Universes where you were born with violet eyes, universes where dinosaurs never went extinct, universes where Earth orbits two suns. They're all out there, forever branching, forever blooming. But what then? What happens after that? Well, first, we have to acknowledge something strange. After infinity, there may be no after at all. Infinity isn't just a big number. It's not like we can reach the edge, plant a flag, and look out over a cliff. Infinity has no edge. It's not a place you get through. It's a state that never ends. So in a way, after infinite universes might be a little like asking, what's north of the North Pole? But here's where it gets interesting. Some thinkers suggest that if we reach a true infinite multiverse, an all-encompassing totality of every possibility, then the question changes. It becomes not what comes next, but what contains the infinite. What context could hold all of existence? This gives rise to the idea of a meta-reality, not just a multiverse, but a structure beyond it, a framework that includes all logical systems, all math, all forms of consciousness, all existence. Let's call it the omniverse, just for fun, a term that sometimes shows up in fringe physics or philosophical speculation. The omniverse would be a set that contains all multiverses, including the ones governed by different logic, different math, different types of being, altogether universes with two time dimensions or no time at all. Universes where cause follows effect backwards. Universes where the fabric of existence is music or dream or something we don't have words for. And if that structure exists, the space beyond even the infinite multiverse, then we might wonder whether it too is infinite. And if it is, then the loop continues. There's no end, just deeper structure. But what if it's not infinite? What if it has boundaries, rules, limits? Then we come to the wildest question of all. What lies outside of existence itself? Picture this. We're not just drifting through a cold starfield anymore. We're floating past the edge of all creation, in a conceptual space where not even ideas exist unless we imagine them. It's not dark because darkness needs space and time. It's not silent because silence implies there could be sound. It's not even empty because emptiness still counts as something. Out here, there is no where, no before or after, no math, no physics, no mind, just the raw possibility that something could be. And maybe, just maybe, that's what sparked all of it. Not a creator, not a design, but the simple, uncontainable pressure of possibility itself. The undeniable fact that once something can exist, it eventually will. So maybe what comes after infinite universes is this: the knowing. Not in a mystical sense, but in a deep, structural one, the understanding that reality isn't about finding an edge, or a final answer, or a place to stop. It's about discovering that there is no edge, no highest level, no last universe, only layers, only questions, only new doors opening forever. Now just stay here with me a while longer. No need to rush back. The stars aren't going anywhere, and neither are the questions. Sometimes it feels like the deeper you go, the quieter things become, not empty, not hollow, just still. Still in a way that holds everything, like deep ocean water that presses gently against your skin. The deeper you descend, the less the noise of surface thoughts seems to matter. You're not just listening now. You're resting inside the multiverse itself, like it's holding you, softly, between folds of time and thought and awareness. We've walked through the major ideas, the branching paths of quantum mechanics, where every outcome exists, all of them, all at once, in a grand overlapping pattern of reality. That's the many worlds view. Every choice you make doesn't erase the other option. It creates two outcomes, both true, both real, each carving its own future through the fog. Then we moved into cosmic inflation, where the expansion of space after the Big Bang didn't stop everywhere at once, which might mean that pocket universes still bubble up beyond the cosmic horizon, forever creating new space, new physics, new stories. That's the eternal inflation multiverse, an endless field of birth and variance. We brushed past the holographic principle, the strange possibility that everything we experience is actually encoded on a distant boundary. A kind of universal film strip where the three-dimensional world is just a projection from a flat reality at the edge of existence. And we explored simulated multiverses too. If intelligence evolves, and civilizations gain power, and computing becomes vast, then why not imagine that we're inside a simulation, a chosen, constructed version of the universe made by beings from another one, perhaps curious or bored or benevolent, running infinite variations just to see how they unfold. If simulations are possible and easy to run, then statistically, it's far more likely that you and I are inside one than outside it. It's a strange thought, but not entirely dismissible. Now, all of that has brought us here, past the definitions, beyond the edges of theory, into the place where all these ideas stop being diagrams and start becoming texture, things you can feel if you slow down and listen hard enough. And right now, if you tune into that quiet space beyond the stars, you might feel it too. That sense that the multiverse isn't just a backdrop, it isn't just physics, it's also a mirror. It reflects back the scale of our questions. It shows us how far we're willing to go in order to understand what this is and who we are inside of it. Maybe we're in a simulation. Maybe we're just one of infinite branches. Maybe this is the only real universe and the rest are just ideas. But no matter which is true, this moment, this single stretch of awareness, this flicker of thought as you breathe in now, it's real. It has weight. It's part of the tapestry, part of the fabric of all that might ever be. Let that sink in. Not just mentally, feel it in your chest. That in the span of all possible universes, there is this version of reality where you are quietly listening to the stars, traveling through ideas not with rockets or telescopes but with attention. The human mind doesn't need wings. It travels across reality with thought alone. And here you are, traveling still. And now, the question that hangs like a star waiting to be named, what happens next? What happens after the multiverse? Not in a narrative sense, not like the next level, but in a deeper way. Is there something beyond infinite universes? What happens if there are no more stories to branch? No more dimensions to stretch? No more space to expand? Maybe nothing ends. Maybe everything just spreads thinner. One possibility is that after eternity finishes, expressing itself in form after form, the universes all dissolve. They cool, stretch, and fade. If the multiverse is governed by entropy like our universe is, then over incomprehensible stretches of time, all forms of energy may decay. Black holes evaporate, stars extinguish, matter decays. Even quantum fluctuations die out. What remains? A flat, cold nothing, a featureless field where not even randomness has a place to hide. But other possibilities persist. Some thinkers believe in cyclic universes that even after total dissipation, the multiverse might collapse and start again, not like a reset button, but a heartbeat. Expand, collapse, expand again, different each time, a cosmic breath, forever breathing out and in. Maybe the current infinity isn't the first, or the only one. Maybe it's just this one version of the inhale, and somewhere deep in the folds of time, other infinities have come and gone, leaving only faint ripples we haven't yet learned how to see. And even beyond that, there are metaphysical proposals that suggest consciousness itself is more fundamental than any multiverse. That maybe the thing holding all of this, all the mathematics and particles and dimensions and gravity, is something we haven't named properly yet. Not a being, not a creator in the old myths, but a kind of awareness that underlies all forms of existence. In that view, the multiverse is like a dream being dreamed by something we don't yet understand, and maybe our awareness is a fragment of that larger one. So what happens after the multiverse? Maybe it all circles back to the same question. Not what is out there, but what is this? This moment, this now, this breath in the dark. You, floating alongside a voice in the black, wondering not because it's useful or required, but because it's beautiful. And if the multiverse has taught us anything, it's that beauty matters. Not because it's measurable, but because it's meaningful. And maybe that's the final truth, that after all the theories, all the branches, all the timelines and bubbles and shadows and reflections, what lasts isn't the data, it's the feeling. That somewhere inside the endless there was something worth noticing, something worth pausing for. So now, after everything, after stars and shadows, bubbles and branches, dust and dark matter, we come to this quiet place, the still point at the heart of all the turning, where everything we've imagined slowly settles, like snow at the bottom of an endless sky. It doesn't feel like a finish line, or a closing door, or even a full stop. It feels more like the last echo of a song that continues humming beneath the surface, even after the notes have faded. You might still hear it now, that low, soft presence, not in your ears, but somewhere deeper, beneath thought, like the way silence after music still carries the shape of the melody. We floated across so many possibilities together, slipped through ideas like dreamers moving through starlight, wandered through quantum branches and inflating space, stepped gently past the edge of simulations and peered into the shadows of higher dimensions. And the question that sparked it all, are there infinite universes? Maybe that's no longer the point. Maybe the real question, the one that matters more now, is, what did you feel as we looked? What wonder rose up when you imagined those endless paths? Because the truth is, no matter how many universes exist, you were here in this one, aware of the mystery, quietly awake in it, willing to wonder. That's not a small thing. That's everything. The multiverse may or may not stretch forever. It may be real in ways we can never reach, or it may be only in the equations, in the language we use to shape our awe. But this universe, the one that brought you here, that let your breath rise and fall, that gave you eyes to see the night sky, and a mind to ask what else might be, this one is real enough. Real because you lived it, real because you cared. And in the grand stretch of all that might ever exist, sometimes it's not about reaching every answer. Sometimes it's about being part of the asking, part of the still, vast, shared moment of simply looking up. And you were, you are, you listened all this way, you stayed close. You wandered, not to get somewhere, but to feel what it's like to move among the stars without needing a destination. That's the kind of journey that changes you quietly. So now, as we slow to a pause, not an end, but a deep breath, let's rest here, just for a while. Let the stars keep spinning out their quiet light. Let the galaxies turn in silence. Let the universes, if they're out there, keep unfolding in their unknowable patterns, because this moment, this one was yours, and that is enough. Thanks for drifting with me. Sleep well, traveler.